You know that cable you plug into your laptop or your gaming console? The one that just works? Well, today we're going to gently pull back the curtain on that little piece of magic. We're going to explore the quiet, kind of invisible world of Ethernet. Because when you plug that cable in, you're kicking off a whole conversation that you never even get to hear.
Right? You plug it in, a little light starts blinking, and boom, you're connected to everything. It feels so instantaneous you don't even think about it. But that simple little click kicks off this remarkably elegant process. It's a conversation that happens in milliseconds. And to really get what's going on, we first have to understand the neighborhood where it all takes place.
See, before your data can shoot across the world, it first has to figure out how to navigate its own block. And that local neighborhood has a very specific name.
We call it a local area network, or LAN for short. Just think of it like a private, self-contained digital community. It's all the devices right there in your home, or in your office, or maybe spread across a college campus, all connected together. This is Ethernet's home. This is where it lives and works, kind of like the set of local traffic laws.
So before your request for YouTube video or a web page even touches the huge global internet, it first has to travel on these local roads. Ethernet is just the set of rules for this local highway system, making sure every little piece of data starts its journey smoothly and gets to the right exit ramp.
Okay, so let's say your computer wants to send a document to your printer, and they're both on this same local network. A really basic question comes up. How does it know where the printer is?
I mean, with potentially dozens of devices all connected, laptops, phones, smart TVs, you name it, how does a piece of data not get totally lost? You can't just shout it out to everyone. That would be pure chaos. The answer is an address. Actually, to get around its local neighborhood and the wider world, every device needs two addresses.
And this is where it gets super interesting. For that local travel, inside your LAN, devices use something called a MAC address. But for global travel, out on the big internet, they use an IP address. They're for two completely different things, kind of like having your name versus having your full mailing address.
The best way to think of a MAC address is like a social security number for your device's network card. It's totally permanent. It's literally burned into the hardware at the factory, and it never, ever changes. No matter where you take your laptop in the world, its MAC address is always the same. And Ethernet, it's completely obsessed with this address. It's the only one it cares about for making deliveries inside the local network.
Okay, so we've got our data and we have a local address to send it to. But what's actually directing the traffic? What's stopping all of our data from just, crashing into each other?
Well, first, the data gets all packaged up. It's put inside something called an Ethernet frame. You can honestly just picture it like a digital envelope. And right on the front of that envelope, two MAC addresses are written down, the senders and the receivers. It's the local mailing label.
Now, this little digital envelope gets sent to the central hub of the local network, a little box called an Ethernet switch. Back in the day, they used a simpler device called a hub, which would just yell the message out to every single device. Super inefficient, kind of messy. A switch, though, a switch is intelligent. It's not a town crier. It's more like a smart, quiet traffic cop.
And the whole process is actually brilliant in its simplicity. When an envelope, or frame, arrives, the switch looks at the sender's MAC address and makes a little note to itself. Okay, this device lives on this specific port. It builds a little directory. Then it looks at the destination MAC address, checks its directory, and forwards the frame only out of the port that's connected to that one specific device. No shouting, no data collisions. Just a quiet, efficient, point-to-point delivery.
But what happens when your data needs to leave the local neighborhood? What about when it needs to travel out onto the global internet? Well, this is where Ethernet's job actually comes to an end.
See, Ethernet's only job is local delivery. That's it. So when it gets a package that's destined for the outside world, it sends it to the one device on the network that has a passport, your router. The router is the gateway, the bridge between your private little LAN and the public internet.
So the switch delivers that Ethernet frame to the router. Then the router takes that digital envelope, opens it up, and pretty much throws away the local MAC address info. It looks inside at that other address, the IP address. And it's the router that then sends your data out onto the global highway, using that IP address to navigate the giant sprawling map of the internet. It's just a perfect handoff.
It's so easy to focus on Wi-Fi and the internet and all the flashy stuff. But this quiet, wired foundation has been evolving for decades, just getting smarter and more efficient behind the scenes.
In the very beginning, Ethernet was what they called a shared bus, which was kind of like an old party line telephone where everyone could hear everything and you had to wait your turn to talk. Then came the hub, which was still a party line, just organized a bit better. And finally, we got the switch, that intelligent traffic cop that gives every conversation its own private, collision-free line. This whole evolution has just been about creating more and more order from chaos.
So the next time you plug in that cable, maybe take a second to remember this invisible foundation. With every single click, Ethernet is performing this incredibly orderly and reliable service. It's the calm, disciplined protocol that handles the crucial first and last mile of your data's journey. And it does its job so perfectly that we never even notice it's there.
Think about it. Technologies have changed, speeds have increased by 1,000 times, but that basic digital envelope, that Ethernet frame, has stayed almost exactly the same. It's just this quiet testament to a design that they simply got right from the beginning, providing the invisible structure our entire digital world is built on top of.